Bada bow! Hey, hello, and welcome to the show, and welcome to the first show of the new year, 2024. Here we are. I'm John Park. This is JP's product pick of the week here for Adafruit. I have a really cool new item for you this week, so thanks for stopping by to watch the show. If you're wondering where the chat is, who am I talking to? Well, not just myself, not just Lars, but also we've got this terrific Discord chat over here. You can head to adafru.it/discord to jump into the chat. You can also head on over to the YouTube chat. Hello, Dave Odessa is hanging out over there. Also, we've got in our Discord Thin Man, Squid.jpg, Jim Hendrickson, DCD, C. Grover, Janiscu7, Sam J. Ohio. Thank you for stopping by. Excuse me, I'm just getting over a tiny bit of a cold. I managed to survive the vacation, vacation adventure. We went to Sweden. We went up way north in Sweden to Kiruna to dog sled and do other cold things, hence the beard. And I was healthy the whole time. Then I got a cold like on the last day and on the plane, so that stinks. But I'm starting to get back over it. I'm going to enjoy some hot tea here. That helps. And that hot tea is a little bit of a clue for today's product pick. Before I say too much more, I will tell you, if you want to go and check out the product pick, you can head to this product page right here, jump in, the product is right there, and this video is playing from right inside the product page as well. And we have a big, humongous discount on this product. We had about 100 of these stashed before the show, so those are back in stock now just during the show. And if you're new, if you don't know how this works during this show, you don't need a coupon code or anything. The product is just discounted. We've slashed it in half. Throw it in your cart, buy it before the end of the show. Sometimes if it's going fast, buy it quicker than that, but it will just revert to the original price after the show. So that's how that works. Head on over there. Fielding a question, Jim Hendrickson, I did not see any aurora. They were, I think the best we had was about a 20% chance the one night when it was not cloudy. We saw amazing stars, but no aurora. But that's okay. We had a plenty great time without the aurora, so that's all right by me. Easy for me to say because I've seen it before from an airplane. I saw it below us in a plane one time, so I've at least got that checked off my bucket list. So before I go any further into this week's product pick, let's have Lady Ada jump back to 2016, September, when this was first released, and then a little revision just happened a couple weeks ago. So this will tell you the story, so take it away, Lady Ada.
Oh, the ADS7830. This is a fun little ADC. We've had people ask, hey, I want to add a lot of analog inputs to a chip or microcontroller or Raspberry Pi. And I like the ADS1015 series, but they're a little pricey, and they're a little pricey. This is much less expensive. It's about half the price, and it has twice.
That's not it at all. I've lied again. All right, hold on. I'm going to bring the video in. Sorry about that. All right, let's see. Can I do this
the ADS7830.
Right,
this is a fun little ADC. We've had people ask, hey, I want to add a lot of analog inputs to a...
And, okay.
Oh, the ADS7830. This is a fun little ADC. We've had people ask, hey.
There, okay. Now we can put this back. Let's see, media files. There you are. Do 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 do.
The MAX31856. This is a universal thermocouple amplifier, and their most popular breakout, I think, is the MAX31855, and that is a K-type thermocouple amplifier. So if you're doing anything with high temperature and you want to measure temperature at a remote location, you use a thermocouple. They can go up to like 1,000 degrees C or more. I mean, they're extremely high temperature probes, like often using kilns, people who are doing beer brewing, people who are doing coffee roasting, like John Park, who I'm sure you built your own coffee roaster. If you're doing all sorts of like science experiments or glass work or whatever you want to do, like barbecue smoking, people use thermocouple, very, very common. And so our K-type thermocouple amplifier only did K-type thermocouples, and depending on the metals in the thermocouple, they have different names like J, T, Q, whatever. And K is the most common, but it isn't the only one. Sometimes people have J-type or N-type or T-type. And so this thermocouple amplifier can do K-type, they can do all of them. So it's a much more universal amplifier because it can handle, I think as far as I can tell, every thermocouple type there is. So it's basically an upgrade for people who are like, oh, well, I want you to have like a J-type amplifier. Well, this one does them all. And in the firmware, when you upload it to your Arduino or compatible microcontroller, you tell it what thermocouple you have attached, and it does all the amplification and noise cancellation and linearization, and it just pops you back a temperature in like 0.1 degrees Celsius precision. And it's like a really great, easy to use amplifier. So I think this will be pretty popular for people who are using something not just a K-type thermocouple, but other types. But it can do K-type as well. So now you have a choice.
We also updated the, this is a, I think, universal, yes, this is the universal thermocouple. So it does a K, J, M, Q, T, R, F, S, whatever thermocouples through SPI. And it's a really great thermocouple adapter shown here with this type K thermocouple. The update is now we've updated the silkscreen a little bit, and it now comes with terminal blocks pre-attached, so you don't have to solder the terminal block anymore.
Okay.
We made it. All right. Whew. That was a bit of an ordeal. Davidessa says, great start of the year, JP. I say, we've only got up to go from here. All right, so let's do this, right? Let me get this name right, 31856. That's my product pick of the week this week. It is the MAX31856 Thermocouple Amplifier. It is a universal thermocouple amplifier, so it can use all the different types of thermocouple probes. So I've got a type K on here, but this will take K, J, N, R, S, T, E, and B type. I think I've used J before as well, but K seems to be the most popular. I have one hooked up right here. This operates over SPI, so I've got some little header pins that I've soldered in there. This one you don't have to solder in the block for the screw terminals. That's already soldered in for you, so you will hook up your pins to plug it into a breadboard or a permaproto or run wires right off of it into your project. You can also skip those if you want to wire directly. And I've got a little demo I'll show here in a second using it with a feather and some breadboard. But what do you need to know about this? So it's universal, it can use all the different types of thermocouple probes. It has a massive range and precision is pretty high. So you can go negative 210 Celsius up to 1800 Celsius. Let me say that again without coughing. It can go negative 210 Celsius up to 1800 degrees Celsius, depending, of course, what the probe is capable of. And it has a 0.07812 degree resolution to it. Runs over SPI. It's fast. It's easy to set up. And we have drivers for Arduino and a library for CircuitPython, so it's easy to interface with it. And what I'll do is let me jump to a little demo view of the world here. I'll put myself up in the cup of ice water there. And I have a breadboard prepared here. I'm going to plug this in carefully to get it right. And so I'm running my voltage, ground, and then the SPI pins and chip select, just as shown in the Learn guide, and I'll show you what that looks like in a moment. And you can see here what will happen is I'll go ahead and plug this in. I'm using a Feather M4 here, and I've got this nice little display here. Gives me a little name of the board, and then I can see what the current temperature of the probe is. So this is the little glass probe with a sealed metal end on it. You can see my ambient temperature right now is 68.2 degrees Fahrenheit. I'll go ahead and plunge that in the icy ice water bath here, and we can see we're getting down to around 37.8 degrees or so. Take that out, and that will rebound, I think, faster if you're not using the metal-ended probe, just because that's got some thermal mass to it. If I grab that with my fingers there, you can see I'm starting to raise that temperature pretty quickly. And then this was some water I boiled for tea earlier, so if I plunge that into there. You can see we're quickly getting up to around 120 degrees or so Fahrenheit. Let's see how my tea is doing. Let me get a sip of it first. And plunge that in there. Tea might be a little cooler because I added some milk, 117.6, so not too far off there. But it is great for any kind of project where you want some large ranging temperature, either really hot, really cold, and you need a way to measure that and then perhaps do an IoT sort of thing, set an alarm, change a setting. Lady Ada mentioned back then in 2016 when I was visiting Adafruit headquarters, coffee roasting, or I mentioned it. I actually did build a coffee roaster. It was just the sort of crank type that I added a motor to. And so I wanted to measure the temperature inside the beans there as I went. It's a pretty common thing to need to do. But if you're building soldering ovens or if you're tinkering around with PIDs for stuff like sous vide cooking, this could be a really good probe for you. It'll go way beyond the range of your typical little temperature sensors. Let's see. Let me look and see if there's any questions over in the Discord chat there. No, we're doing good. So let's have a look then at the main page for this. So I'm going to go over to the product page. If you scroll down, you'll see check out our tutorial for wiring diagrams, files, software, and more. So here is the main Learn guide. This tells you all about it. We've got a pinout page on here. There's some little extra features beyond the pins that I'm using and what I've shown here. You can also use a fault pin that will let you know if you've got a fault, and also if you need to have a particular period that you don't want to just set in the code. You can use this DRDY. I think that's a delay for read. You don't actually need to use that in our case because we have that covered in the library. But those are the extra pins on there. Otherwise, this is pretty standard SPI connections with chip select there, voltage, ground. And then if you take a look, here's the wiring diagram, setting that up on an Arduino. I've got it set up. I think there might be another diagram in the CircuitPython section for the feather, which is how I have it set up right here. And then we've got a code example here that is very easy to use. In fact, let me show you what that looks like. I'll jump to this view right here. So you can see we're about 65 degrees in the workshop. Stick it in the ice bath there and let that cool. And here is my code. So the important things here, I'm importing the MAX31856 library. Then I am setting up SPI bus on my board. I have set up pin 5 as the chip select and set up that pin as an output. And then this is all it takes to create the thermocouple object. So I'm saying thermocouple equals Adafruit MAX31856 on SPI with the chip select pin that I set up here, D5. I'm doing some display stuff. And then to check the temperature, all you really need to do is ask for thermocouple.temperature, and it'll spit that back. It spits it back in Celsius, so you can do a little conversion like I'm doing here. I've created a variable called temperature Fahrenheit, and I'm doing this little formula here to convert that to Fahrenheit. And then I am printing that. You can see in my REPL there, I'm actually printing it with a higher level of accuracy that I'm showing on the LCD just because I ran out of digits on there since I got fancy and used the degree symbol and the F there. But you can get quite a lot of granularity out of it. Plunge that back into the hot there. You can see here I'm getting a temperature readout of 113.30, 113.80, and on. So that is all it takes to print out, or in the case of my little LCD display featherwing there, I'm saying display.print, and then pretty much the same thing. So let's see, what questions have we got? It is straightforward to use. Like Lady Ada said, there are provisions for choosing different types of thermocouples in, at least in the Arduino library. I haven't tried it out in CircuitPython. I'm assuming that it is. And in fact, just as a little bonus, let's see if we can, if we're trying to find that out, here's how I'd go about it. I'd do read the docs and the name of the library, and I would look for the CircuitPython version of it. Let me bring up my browser here so you can see that. So here's the read the docs. And you can just scroll through this, or you can check out some of the little table of contents on the left here. But you can do some set averaging, set the fault, a one-shot measurement. You can adjust the noise rejection, set a reference temperature. And then here you can see thermocouple type. Yeah, so we do have that here. If we look at that, it is simply name of the board that how you've instantiated it. So Adafruit MAX31856 Thermocouple type, and then you just tell it BEJKNRST. The chip takes care of the rest. It deals with the different bimetal pairs, which is how this works. There's two types of metal in the probe, and the difference between them at different temperatures creates different voltages. So this is ready to go with those, as well as doing all the noise rejection and amplification that you need to get a nice stable value out of it. So let's see, other questions. Oh, DCD says my question probably scrolled off. Okay, let's see what this is. There we go. To get high accuracy, the cold reference junction temperature needs to be known also, right? I don't know about this. If anyone in the chat knows, or maybe ask on Ask an Engineer, see if Lady Ada remembers talking about this and how this works, but I don't know enough about it to know about the cold reference junction temperature and how to calibrate for that or set for that. Maybe C. Grover does. C. Grover knows a lot about calibration and does, I think, some temperature measurement for household stuff. All right, let's see, what else? Am I forgetting anything? There's the picture of the board there. You can see it tells you all the thermocouple types on the silk screen on the back there. You simply screw in the two wires of the thermocouple to that little terminal block there, and it's good to go. I'll go ahead and unplug this now and pull the board from my breadboard. So head here. That's where you can buy it. I think we still have some in stock. Let me double check. Yeah, we have 72 of them in stock. You can get up to 10 of them. So if you have big plans, this is the day to do it. Maybe you're setting up a beer brewery or distillery, and you want to create some roll your own thermal gauging. This is maybe a good way to do it. I should also mention actually that you will want to pick up one of the thermocouples that we sell. If you go to the product page for the board, 3 of them show up over on the side there, and you can just click on include. If you want to take a look at those, this is the one I'm using. This is a glass braid insulated steel tip type K, and then we also have the without the steel tip on that, and I'm guessing, again, that one would rebound quicker between temperatures because it doesn't have the little steel tip on there. All right, other questions? Let's see, TIF is a series of dots. Looked like reference temperature functions mentioned cold junction temperature in the docs. Okay, yeah, so maybe check out this read the docs page to find out more, and I can post that. Let's see, I'll post that over in the chat. That's for CircuitPython. There's also a read the doc for Arduino driver as well. Right, have we done it? I think we've done it. So that's going to do it, right? This is my product pick of the week this week. It is the MAX31. That's my product pick of the week this week. It is the MAX31856 Thermocouple amplifier with universal thermocouple probe types. Let's say that one last time and get it right. That's my product pick of the week this week. It is the MAX31856 Universal Thermocouple Amplifier. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, first one of 2024. Thank you everyone so much for stopping by. Go get yourself some thermocouple-y stuff and measure some things. All right. Thanks everyone. I'll see you soon. Bye-bye.